The question is the value of PV for 5.6 liters of an ideal gas is dash RT at NTP. So the ideal gas equation, we know it is PV is equals to nRT, and at NTP, which is the normal temperature and pressure, the temperature it is 273.15 Kelvin and pressure is 1 atm, and volume it is given which is 5.6 liters. So here we have to calculate the value of PV is dash RT. So we have to calculate this value of N. So this N will be PV upon RT. So now if we put the values here, so we will calculate the number of moles. So this N will be equal to the pressure which is 1 atm into volume, it is given 5.6 liters, divided by the R which is gas constant, its value is 0.0821 liter atm per Kelvin per mole into the temperature which is 273.15 Kelvin. So from here, as we can see, this atm will get cancelled out, this Kelvin inverse with Kelvin and liter with liter. So the number of moles will come out to be 0.25 moles. So it will be PV upon RT, which is N. So it will be 0.25. So this PV will be 0.25 RT. So here it will be 0.25 RT.
Hello, the given question is that Cp minus Cv for an ideal gas is, okay. So here what we have to given is fill in the blanks is given, that is Cp minus Cv is equal to what, okay. So we know that at constant pressure, okay, at constant pressure, that is P, the heat given as, that is Qp is equal to nothing but Ncp into delta T. Also this value is equal to change in enthalpy, okay. So this value is nothing but change in enthalpy. So you can say that this Qp is equal to nothing but Ncp delta T is nothing but delta H, okay. So this is the first equation, that is Qp is equal to Ncp delta T is equal to delta H, okay. Now similarly this is at the constant pressure. So now next is at constant volume. At constant volume, this Qv, okay, is nothing but Ncv into delta T, and this value is equal to change in internal energy, okay. So this value is nothing but change in internal energy, okay. So what we will do, we will equate with this, okay, and this is the value, that is Qv is equal to nothing but Ncv delta T, which is nothing but delta U, okay. So this is your second equation, okay. Now also we know that the relation between delta H and delta U and delta P is nothing but, that is delta H is equal to delta U plus delta PV, okay. So this is the standard relations, okay. This is for, let us assume, for 1 mole of a gas, okay. So this is the relation. What we will do, we will substitute the value of the given data, okay. Also, since this is an ideal gas, okay, since it is ideal gas, so from ideal gas equation we know that that is PV is equal to nRT, okay? We know that for ideal gas PV is equal to nRT, okay. And since it is given as for 1 mole, so we will substitute that is value of N, and we will get PV is equal to RT, okay. Now what we will do here, substitute the value of each of the given that is following data, that is delta H. Delta H is nothing but Ncp delta C, so here we will substitute, okay. So delta H is nothing but Ncp delta T, and delta U is nothing but Ncv delta T plus delta, in place of PV we can substitute RT, okay. Now what will next step is nothing but Ncp delta T is equal to Ncv delta T. This R is constant, so we take it out, that is outside, that is R, and we will get delta T. Since it is given for 1 mole, so here the value of N will be 1. So here Cp delta T is equal to Cv delta T plus R delta T. Okay, since delta T is common, so we will get Cp is equal to Cv plus R. Okay, now the next step is nothing but Cp minus Cv is equal to R. So that is the final answer. Okay, that is Cp minus Cv is equal to R. And here what is the filling blanks? That is Cp minus Cv is what? So Cp minus Cv is nothing but R. Okay, I hope this answer your question. Thank you.
Hello everyone, we have this question where a mixture of ideal gases is cooled up to liquid helium temperature, that is 4.22 Kelvin, to form an ideal solution. Now we have to say whether this statement is true or false. Now this statement is absolutely false. Now let us give the reason for that why we are saying this is false. We need to give a justification. Now the reason is that ideal gases are basically hypothetical systems, or you can say hypothetical gases. They do not exist. Here the pressure, volume and temperature all are according to the gas equation, that is PV equals to nRT. All the ideal gases come under this equation, that is their pressure, their volume, temperature, everything can be calculated using this equation. Now all gases are actually real. There is no question of ideal gases. All gases are real. They do not obey the ideal gas law, that is this law. Let us write it down. They do not obey the ideal gas laws under conditions of temperature and pressure. Under all conditions of temperature and pressure. So now we will also see that what were the wrong assumptions. Now according to KTG, the wrong assumptions were that the volume of gas particles is negligible in comparison with the volume of container. Now these are wrong assumptions. In comparison with that of container. We know that gas molecules do have some volume. They are not negligible for sure. Now the second one, that is there is no interaction between gas particles. This is also wrong, as we know that gas molecules also have some kind of interactive forces in between them. So these two assumptions are wrong. Therefore, a mixture of ideal gases when cooled up to liquid helium temperature cannot form an ideal solution because there is no force of interaction between the molecules. Now, according to ideal gas equation, there is no force of interaction between molecules, but we know that all gases are real and they do have certain forces of interaction between them. So this statement is completely false. a mixture of ideal gases cannot be cooled up to helium temperature to form an ideal solution, because firstly ideal gases do not exist and ideal solution cannot be formed because then there will be no force of interaction between the molecules. So this is your complete answer. Thank you.